My name is Renette Edgar, and I'm a program facilitator with the Regina District Industry Education Council. Today we are filming on location at Dumur Industries, East Regina. Today I'd like to welcome Derrick McConnel. Derrick will take us through his job, what happens for him at Dumur. We are so excited to be here today. Take it away, Derrick.
Hi, Renette. Thanks for the introduction. My name's Derrick McConnel. I've been here for roughly 17 years. I graduated high school in 2004, and after a short year break, I went and took the pre-employment welding course at SciAst, or Polytech, in Moose Jaw. Following completion of that in April of 2006, I then started working at Dumur Industries here as a TIG welder. And through that, I worked as a TIG welder for 12 years. With some opportunities opening up, I then moved into a supervisor role for the manufacturing supervisor, which entails a couple different areas. There is lasers, plasma, punches, brakes, plating, and assembly. Right now, you can see behind me, we are in the laser departments. We currently operate 2 lasers, one being a flat cut laser, capable of cutting aluminum, stainless, or any other normal types of steel up to 3/4 of an inch thick. The other laser on this side is a 5-axis laser, and what we do with mostly for it is a lot of fixturing jobs, cutting in 5-axis positions that normally you can't produce parts in, which gives us a large opportunity for work in Saskatchewan and all over the world. And I believe there's only one of them in Saskatchewan at this time.
So maybe we'll just take a walk and maybe have you show us some of the equipment that you've got within the sections that you supervise, if that's okay?
Okay, sure.
Is there like a step one of the process that you kind of supervise or start with? Like, is this kind of the start of your job?
Part of my job is starting the whole process for the shop. Raw material comes into this end of the building for the most part. And my machines that I operate or supervise manufacture it into parts and move it on to further processes. So behind this stack of steel here is our flat cut plasma machine. Currently we process all sizes of sheets from masters that are 8 feet wide by 25 feet long with an inch thick. We do cut up to thicker steels. The sheets aren't as large, but we can cut up to 3-inch thick steel plate on it. And after that, they get moved on to processes like machining, laser, and other processes. So.
Awesome, thank you so much.
This is my operator, Brian. He operates the 5-axis laser and the flat cut laser, depending on our schedule and what it looks like. Right now, we are working on some stamped parts. Obviously, it's a little unachievable to hit certain tolerances with the stamping process. So what we do is we stamp a large blank and then load it onto a jig on this laser. Brian then takes a program that's been created by our programming department and using 3D printed objects to get him an idea of what it's going to look like, what we got to do to manipulate it. We then create a program and modify anything we need to make it work on the laser. Good? So Brian will just be running the laser now, and this is what it looks to do a full profile cut on one of the stamp parts that we work on. Brian, do you want to just touch base on how many hours are involved in proving out a first part?
Well, this particular part here, being a brand new part, it's probably about somewhere between 6 to 8 hours invested in modifying the program that comes from the programming department in order to make this cut the way it should cut, as far as feed rates, as far as cutting conditions and stuff like that. It's a fair bit of work involved to get the result that we have that you see here now.
So there's always going to be a lot of fine tuning when it comes to stuff like this. The program gets us close. That comes from the programming department. And then with all the fine tuning and stuff that Brian does, that's how we get our cut quality down, our edge quality good. and how we end up with a good quality part. One of the more challenging parts that we do have to work on, just with the proximity of the jig and how the head operates, because there's a lot of close contact areas that could damage the laser itself if we ram it into anything or crash the head. So that's the finished part. Brian's had a lot of experience. He's one of our most experienced operators in this department. Brian, you want to touch on anything as far as what kids need to know to do something like this?
I suppose you need to get a job at Dumur Industries, and this is the only place you could be trained to do such a thing in this province, to the best of my knowledge, with three-dimensional cutting. As far as I know, I don't think anyone else in the province is doing it. So, and because this machine is a special machine because it has a much higher wattage resonator on it than your average machine would have, that gives us the capability to do some parts like this and even heavier than this. Just as an example, this was just a flat cutting example, but that's 5/8 of an inch thick. That's just a sample I keep around to show people what it's capable of. Yeah. And that's, you wouldn't find that anywhere else for probably across Canada with a machine like this. So yeah.
All right. Thanks, Brian.
Yep.
So this laser here, as I said, is our flat cut laser. This processes the majority of our material that comes into the shop for flat cutting. All of the pieces either go straight out to paint or to forming or to machining to be moved on to other areas like welding and paint after that. Working in these departments requires a lot of skill. You need to have special certification to run cranes, and obviously my job would entail that these guys are doing their job properly and safely in an efficient manner.
So obviously there's a lot of rewards that go along with having a job like this, and maybe even in your position as a supervisor. Would you be able to tell the students some of those rewards? What are some of the things that makes you get up in the morning and want to come to work?
Well, obviously the place is a very good place to work. The people that work here are very good. It's kept me working here for 17 years. And it's basically the first job I've had outside of high school.
Outside of that, what are some of the challenges or stressors that you experience on the job as well?
Some of the challenges and stresses would be a lot of the criteria for our job as far as tolerances on parts, material quality, making sure we're processing things in an efficient manner, making sure we're hitting our deadlines, our schedules, managing the workload and all the rush jobs that come through. So those would probably be the biggest challenges and stresses. Being a supervisor for people, obviously you're managing people. Everybody has good days, everybody has bad days. That's another challenge.
Yeah.
But Dumur afforded me the opportunity to move up into a role like this with proper training and courses to handle that kind of stress loads. So.
That's awesome. Thank you for sharing that.
So this is our brake department. All the parts that come off of, or most of the parts that come from the lasers and the plasma and other manufacturing processes like the punches usually end up here performing. Currently we have two operators. Corey is operating our 14-foot, 250-ton brake right now. Currently bending steel. We bend anything from steel to aluminum to stainless. The other brake that we usually use is the RG80. It's a 8-foot, 80-ton brake. A little more versatile. We use it for a lot of stainless and aluminum jobs that we currently work on. As you can see, these are the blanks that come in. And when we are done forming, obviously there's inspection processes that we have to work on to ensure that our tolerances are being met. Anywhere from radiuses to bend angles, proper leg lengths on the parts. And Corey's going to be forming one here right now. So this is another part of our process for manufacturing raw material. Raw material comes in on skids where we shear it behind you into blanks for our punch department. The punches that we have here are a Trump and an Amada. Trump would be a little more purposed for lighter materials, a little more finer work, and the Vipros behind us would be a little more for heavier aluminums and stuff like that. We do a lot of punching on 1/4-inch aluminum. Our operator here right now, Igor, is punching brass sheets and ID tags. And as you can see, he's just about to start running the punch right now.
So when students get hired on for a position, are they being hired specifically for a job, or are there a series of jobs that they would be doing?
A lot of the times, previously we had a lot of in-house training. A lot of people either applied for jobs that were posted in-house, or if we have trouble finding people for those jobs, we then look outside of Dumur Industries and try and hire somebody with a specific skill set.
Awesome, thank you. That he's working on right now?
So the process that he's working on right now is actually quite a lengthy job, just due to the sheer quantity and the number of hits in the program itself. The job usually takes about a full week of work, so about 40 hours to complete one job. That's with a larger job quantity, so if it was a smaller quantity, obviously less time. But most of the jobs that we do process in this department run around anywhere from 3 to 5 hours on average.
I look at the way things are set up in Dumur, and it's very well organized. You know, I think that's probably needed for something this size when you're manufacturing this kind of material.
Being here as long as I've been, and with taking this role, they've offered a lot of courses to upgrade, obviously, my skill set. And a number of us have gone for lean manufacturing training with the yellow belt and the green belt in lean manufacturing. Obviously, the more efficient you are, clean you are, more organized you are, it helps you build better parts, looks better, looks more professional.
Exactly.
Yeah.
Yes. That's
a better quality product. So this is the assembly area that we're moving into now. All the parts, after they have been processed by either welding, forming, and laser cutting, braking, usually end up in this area, whether it be for final part mark before they get shipped down to inspection. A lot of the tanks that we form and build have to come down here for pressure testing. They have to meet a certain criteria before they can be sent out, make sure there's no leaks. Any hardware that has to go on finished parts needs to be added onto the part itself and assembled. And this is Bob, our operator here. He's been doing this as long as I've been here, and has been doing a good job of it. So. The last area that we'll be checking out is the plating department. And it's one of the either first or final steps in our process for manufacturing. So once all the parts that I have taken you through with the areas have been punched or formed or laser cut, they get staged in receiving, which I'm sure you guys will touch on. And they will then come to the plating department. So our plating department is a series of tanks, cleaners, material preppers that prep all our metal for either welding or paint or for final assembly to go shipped out.
So your finished products get basically shipped all over Canada?
I think most of our finished products either go down into the States or they go to Ontario for the most part. So this is our plating department. For the most part, it's basically a chemical dip. When the parts come here, they get staged in a work order to go to welding. They get dipped in an acid bath to clean the oxide layer off of the material, then rinsed off, and everything gets put back on the pallet to get shipped over to the welding departments, which helps obviously for aluminum and stainless and stuff like that, helps clean the parts so that the welds are good and we don't have any issues with that. Once everything has been done welding, manufacturing, or machining, they then sometimes come back to this department where they then get dipped in special chemicals that prep them for certain types of paint or anti-skid that gets sprayed on them. And then they would get wrapped and shipped to, or packaged over to shipping.
Shipping, awesome. Awesome.
Okay.
Okay, well, I think on behalf of RDIEC, I'd like to thank you so much for taking the time with us to spend this morning to walk us through the different steps of your department. And I know there's going to be interested students that are wanting to hear this presentation.
Absolutely.
So thank you.
I look forward to it. Thank you very much.